All right. Hi, everyone. This is part 2 of your exam review. I'm going to be going over parts 12 C and D. Let's get started. Our first question is I to the negative 29. So the first thing that I notice about this problem is that we have this negative sign here. So I'm going to have to deal with that right away to make the problem easier. And when I have a negative in the exponent, that just means I can drop that that part under the or into the denominator. So I now have 1 over I to the 29. The next thing I want to do is I want to split up my exponent into two parts. One part that is a factor of 4, and then the part that is not. So in this case, the closest thing that is lower than 29 is 28. 28 is divisible by 7 and 4. So that means that I can change this exponent into 28 plus 1. And that means that I can now rewrite this as 1 over I to the 28 times I to the first. Right? And so if we go to our I rules, we know that I to the first is just I squared is negative 1. I cubed is negative I. And I to the fourth is equal to 1. And then when we go to I to the 5 or I to the 5th, we circle back around to I. We start over. So since I to the 28 is divisible by 4, that means that it's equal to 1. So now we're left with 1 over I to the 1. However, I to the 1 is just I, so we have 1 over I. We cannot leave I in the denominator now. So in order to get it out of the denominator, we're going to multiply by 1. And that 1 is going to be I over I, since I divided by I is equal to 1. And that leaves us with I over I squared. If we look at our rule, I squared is equal to negative 1. So our answer is I over negative 1, or negative I. Why is this not writing? Oh, I must have negative I. Oh, there we go. All right, so this is our answer. We can box it. For the next problem, we have I to the 46. So we don't have a negative exponent this time, so we can just leave it and go straight to the second step. The closest factor of 4 is 44. So I'm going to split this. My tablet froze, so I'm going to say that again. For our next problem, we're going to look for the next lowest divisor of 4, or number that can be factored by 4, and that in this case is 44. So I'm going to split this into I to the 44th plus 2. Which is equal to I to the 44th times I squared. And if we go to our little chart up top, we know that 44 is just equal to 1, and I squared is equal to -1, so our answer is -1. All right. So, problem 13. We're going to perform the indicated operation and write our answers in standard form A plus BI. So here, we're just adding. We can only add like terms here. So in this case, we have a 5, we just have a number, and then we have 2i, which is a number times an imaginary number. And then our next problem, we have a 6, and then we have a minus 5i. So that means we can only combine like terms, and that means we can only add the 5 and the 6, which is equal to, oops, pick up here. Which is equal to 11, and then 2i minus 5i, since this is negative, is going to be -3i. And we have our A and our B, so this is our answer. Here, we're going to subtract. So we have a 2 here, and we have a -4 here. And then here we have a -6i and a +6i. So here, I'm going to distribute this negative sign first. So we have we have 2 minus 6i plus 4 minus 6i. Put these back in parentheses. And now we can add them like we did before. 2 plus 4 is 6. -6 minus 6 is -12. And we have our A and our B term, so that is our answer. Here, we are multiplying. So we can't just multiply 4 times 5 and -7 times I. We have to FOIL, because there are 2 terms in each term we are multiplying. So we have to FOIL. So we're going to do our firsts first. So that is equal to 20. And then we're going to do our outsides, which is plus 4i. And then we're going to do our insides, which is -35i. And then we're going to do our lasts, which is -7i squared. We're now going to combine terms. So we have 20 minus 31i and then minus 7i squared. Now, notice we have this I squared. If we look back up top, I squared is equal to -1. So we now have -7 times -1, which is equal to just 7. So now we have 20 minus 31i plus 7, which then gets our answer to 27 minus 31i. We have our A term and our B term, so that is our answer. We can't just leave it in this form because we want it to be in this form up here, and this I squared is solvable. We can make it -1, so we're going to want to convert that into -1 and continue with the problem. And now we have an A and a B term, and we don't have that I squared term. Alright, so here we have a fraction. We cannot have this I in the denominator, so we're going to want to get rid of it. The way we get rid of it is we multiply by its conjugate. So that means we're going to multiply by 3 plus I over 3 plus I. We're multiplying by 1 here. So that means that's going to be equal to, and we're going to have to FOIL. So that's 12 plus 4i plus 9i plus 3i squared. All over, we're going to have to FOIL this too. 9 plus 3i minus 3i minus I squared. And so now we're going to combine like terms. We're going to evaluate these I squareds. So this is now going to be -1 times -1, which is equal to 1. It's going to be 3 times -1, which is equal to -3. So now we're going to have 12 minus 3, which is 9, plus 4 plus 9i, which is 13i, all over 9 plus 1, which is 1, which is equal to 10. And then these 3 plus 3 and minus 3 cancel, so we're left with nothing. So that means that our final answer is 10 over 9 plus 13 over 10. We have our A and our B term, and so we have our final answer. The reason we multiply it by the conjugate here is because it gets us here to this term where we have this 3i minus 3i, and the i's cancel, and we no longer have an I in the denominator. We have plus 0i, which is what we want. Alright, moving on, we have solved the quadratic equation by factoring and then apply the zero product property. So, we have this quadratic equation here. The first thing we want to do is we want to get everything on the same side. So we have x squared minus 10x minus plus 9 is equal to 0. Since we have this in a proper formula, I noticed that we have this 9 here and this -10 here. That means that our factors, we can split this up into x squared minus 9, or minus, I want to make this squared, minus 1x and minus 9x plus 9 is equal to 0. And now we can take out like terms. So here we have an x minus 1 here. And on this side we have minus x times x minus 1. And that means that this equation is equal to x minus 9 times x minus 1. And that is equal to 0. So we factored it. We're now going to apply the zero product property, which means if one of these terms is 0, then the whole thing is 0, because we're multiplying by 0. So if this first term was 0, that would mean x minus 9 would be equal to 0. And if we move the 9 over, then x would be equal to positive 9. And if we do the same thing with the second term, that would mean that x minus 1 is equal to 0. We can add the 1, and x would then be equal to 1. So we have x is equal to 1 and 9. All right, the next problem is solve the quadratic equation using the square root property. So, because we have a squared here, that means we can just square the whole term, because this is equal to a squareable term. So if we have x plus 1 squared is equal to 9, we can square root both sides. Since we are square rooting a square here, that would be like square rooting that would be like saying if I had not, so for example here, if I had 9 squared, that is obviously equal to 3. However, negative 3 times negative 3 is also 9. So that means that I have to write this plus minus sign here to indicate that it can be the positive side and the negative side. So, since I square rooted that, the square and the square root cancel. And I now have x plus 1 is equal to plus or minus 3. I'm now going to split up the plus minus, and I'm going to have x plus 1 is equal to 3, and x plus 1 is equal to negative 3. And so I'm going to subtract 1 here and get x is equal to 2, and then I'm going to subtract 1 here and get that x is equal to negative 4. Right? And we can go back and check. So if we plug in 2 for x, we'll have 2 plus 1 squared, which is equal to 9, which is equal to 3 squared, which is equal to 9. Here we have negative 4 plus 1 squared, which is equal to negative 3 squared, which is also equal to 9. So that's how you solve a quadratic using the square root property. All right, here we're going to solve by completing the square and then using the square root property that we just talked about. So, first thing is to move So the first thing we want to do is we're going to want to move the c term over. So we now have x squared minus 6 is equal to negative 11. We now want to determine what our new C term is. And the way we do that is we take our B term, which is negative 6, and we divide it by 2. So that is now equal to negative 3. We're going to want to keep this number in mind for later in the problem. We're then, for our C term, are going to want to square it, which is equal to 9. So now that we have that 9, we're going to have x squared minus 6x plus 9 is equal to negative 11. However, since we added 9 here, we're also going to want to add 9 on this side of the equation to keep the equation balanced. So we're going to add 9 here. So now, since we just completed the square, we're going to want to put this in a squared factor form here. And we're going to do that by looking at this root here that I said we're going to use later. So this is going to be equal to x minus 3 squared. And I got that from this number, this negative 3 over here, because of the way we FOIL. Whenever we FOIL, we're going to do x minus 3. Let me write it out. We have x minus 3 times x minus 3. We're going to do this x times this 3 and this x times this 3. So we're going to have two negative 3x's. So that's why we divide by 2 here. And then when we do the last terms, we're going to have negative 3 times negative 3, which is 9, which is why we have this 9 here. So that's how completing the square functions is. We are basically determining this root here. So now that we have that, oops, go back to my pen. We're going to solve this side of the equation, and that's just going to be equal to 2. So we're going to do the same thing that we did in the last problem. We're going to square root both sides. The square root of 2 is not anything, so we're going to leave it. So we now have x minus 3 is equal to the square root of 2 plus or minus, because we square root a square. And now we have x is equal to 3 plus or minus 2. Oh, excuse me. This is actually negative 2i, or negative 2, the square root of negative 2. So that means here we're going to have negative 2, and here we're going to have negative 2. So we're going to have to take that negative out. And the square root of a negative is I. So we can take the I out. Like that. Because this is negative 11 plus 2 is actually negative 2. Negative 2. All right. So solve this by the quadratic equation using the quadratic formula. All right. So the first thing I'm going to do here is get all my terms on the same side. So I'm going to move this 2y over and put that at the start. So we're going to have 2y squared plus 5y minus 1 is equal to 0. Since I have that, I can now use, I have my A term, my B term, and my C term. So I can use the quadratic equation which is this. So I'm going to start plugging in numbers. We have negative b, which is 5. So we're going to have negative 5 plus or minus the square root of 5 squared, which is 25, minus 4 times 2 times negative 1 all over 2 times 2. And we're going to simplify this. We're going to have negative 5 plus or minus the square root of 25 plus 8 over 4. 25 plus 8 is 33, which does not go into anything in the square root, so we're going to have to leave it. And so this is our final answer. Here. All right. Question 18. For each of the quadratic equations, evaluate the discriminant and determine the number in the type of solution. So here, the discriminant is all of the numbers under the square root in the quadratic equation. So b squared minus ac. So if this number is equal to 0, then there's two solutions of the same number. So there's only one solution. If it is equal to a number, then it has two real solutions. If it is a negative number, then it has two not real solutions. So let's see what this problem brings us. So for A, we have the square root of negative 20 squared minus 4 times 4 times 25. So this is now 20 squared is 400. 4 times 25 is 100. And then that means we have 400 minus 400, which means we have the square root of 0, which is equal to 0. Since we have this 0, that means that this is a square, and it will have the same solution. So that means we'll have one real solution, because we'll have two of the same solutions. For the next part, we're going to do the same thing. So here we're going to have the square root of 7 squared minus 4. Oops. Minus 4 times 5 times negative 20. This is equal to the square root of 49 minus 20 times minus 20. So that means we're going to have the square root of 49 plus 400, which is equal to the square root of 249. Since this number is positive, that means we're going to have two real solutions, because we're going to have a plus minus here. That means we're going to have a number plus the square root and then a number minus the square root. For this next part, we're going to have to solve it a little bit. So we want to get everything to the same side, so we're going to minus 4t plus 11 minus 4t plus 11. And we're now going to have, hold on, let me move this down. We're going to have 5t squared minus, or plus t plus 1t plus 11. All right, is equal to 0. So if we look at our square root discriminant, we're going to have 1 squared minus 4 times 5 times 11, which is going to be equal to 1 minus 20 times 11, which is equal to the square root of 1 minus 220, which is then going to get us the square root of negative 119. Since we have a negative square root, that means our solution is going to be imaginary, so we're going to have two non-real solutions. All right, and then we're now going to solve for this equation here. Notice that is quadratic. We have t squared t, and then a c term. So we have a, b, and c. Just because we don't have numbers doesn't mean we can't use the quadratic formula. So we're going to do that here. So we're going to have negative v naught plus or minus the square root of v naught squared minus 4 times AO times SO all over 2 times A naught. And since we don't really have numbers, this is all we can do. So T is equal to this whole thing. And it will have 2 roots. All right, next page, 2 parts. Our question 26, part A and B. We have some word problems now. Oops. All right, so we have a rectangular piece of carpet that covers 200 yards squared. The width of the carpet is 9 less than the length. Find the length and width of the carpet, round to the nearest tenth. So we have a length and, I'll make that big L, and a width. We know that the width is 9 less than the length. So we're going to denote that as L minus 9. We also know that we're looking for an area because we have a rectangular piece of carpet that's 200 yards squared. So we're looking for an area. Our area is 200 yards squared. We also know that our area is equal to the width times the length. So if we substitute everything in, we know that A is equal to 200. We know that our W is equal to L minus 9. And we know that our L is just equal to L. So we can simplify this equation to L squared minus L, and then take the 200 over also. Here, minus 200, minus 200. And we now have an equation like this. We can now use our quadratic formula again. So we're going to have 9 plus or minus. I'm going to rewrite it at the top. Excuse me. Negative b plus or minus b squared minus a 4ac all over 2a. So negative 9 times a negative is 9 plus or minus the square root of negative 9 minus 4 times 200 times 1, all over 2 times 1. So here, we're going to have 9 plus or minus the square root of 881 over 2. And we are now going to simplify that. So, this means we have 9 plus the square root of 888 over 2, and 9 minus the square root of 881. So if I put that into my calculator, I get that this is equal to 19.3, since we went around to the nearest tenth. And if I put this into my calculator, I will get negative 10.3. This number here is negative. We cannot have a negative length because that would make no sense. So we're going to get rid of this answer, and we're going to be left with this answer. This is our length. However, we also want to find the width. And we know back from the start that the length, or the width, is 9 less than the length. So that means if we subtract 9, we will get 10.3. And that means our length is equal to 19.3 yards. And our width is equal to 10.3 yards. All right. In a classic Seinfeld episode, Jerry tosses a loaf of bread, marble rice, straight upwards to his friend George, who's leaning out of a third-story window. If the loaf of bread leaves Jerry's hand at a height of 1 meter with initial velocity of 18 meters per second, use the model, the equation here, to write an equation for the vertical position of the bread in S meters of S in t seconds after the release. Then use the equation to determine how long it took to reach George's hand if he catches the bread on the way up at a height of 16 meters. All right, so first we're going to find our equation. So we're going to do it in terms of S and T. So we're going to leave it here. We just have our S, because that's what we're looking for. That's what we're equal to. Our G is gravity, which is equal to 9.8 meters per second squared, times T squared, plus V naught. V naught is our initial velocity, which is 18 meters a second. So we have 18 T plus SO, which is our starting height, which is 1 because his hand was 1 meter above the ground. So if we simplify that a little bit, we'll get S is equal to negative 4.9 T plus 18T plus 1. And now we want to find how long it took for it to get to his hand at a height of 16 meters. So that means, I'll box this, that means our S is equal to 16. So we now have negative 4.9 T squared plus 18T plus 1 is equal to 16. So we can move that 16 over, like that. And now we can use our trusty quadratic formula to get negative 18 plus or minus the square root of 18 squared minus 4 times negative 15 times negative 4.9 over 2 times negative, 4.9. There. So I'm going to put that square root into my calculator. So I have 18 squared minus 4 times negative 15 times negative 4.9. Oops. And I'm going to get 18 squared plus or minus the square root of 30 over negative 9.8. I'm now going to analyze this equation with negative 18 plus the square root of 30 over this and also the negative. So I'm going to put this into my calculator. Alright, and here I got 1.278, and here I got 1.396. So, oops, this is squared here. So I know this equation here is a quadratic and it's negative. So that means it is going to look like this, basically. That means it's going to go through a certain y value twice. So that means it's going to go up and then the bread's going to come back down. However, George is going to catch the bread on the way up. So that means we're going to know it's going to be the earlier time, and it says round to the nearest tenth. So our time is going to be equal to 1.3 seconds. All right. So this says solve the polynomial equation. Something that I noticed from this equation first is that it's all divisible by 2. So we're going to divide both sides by 2. 0 divided by 2 is just 0, so that means I have 2x cubed minus x squared minus 3x squared minus 10x plus 15 is equal to 0. And that's just going to make my life a little bit easier. I now have to check my factors of 15. So 15 is divisible by 1 and 15 and 3 and 5. However, it is also divisible by the negative ones. So that means, for instance, that my 3 roots could be 1, or -1, -1, and 15. That all multiplies to positive 15. So here, I'm going to erase this. Give me more room. Here. Okay. So the first ones I like to try are 1. Here I'm going to use synthetic division. Or hold on. I'm sorry, I take that back. I will not be doing that. Here, I have 2 multiples of 5. So, that means I can take a 5 out here. And here, I have a factor of 2x, so I can take that out. So I now have 2x minus 3 times x squared minus 5 times 2x minus 3. And I now have these 2 solutions here. So I can rewrite this now as x squared minus 5 times 2x minus 3 is equal to 0. And I can now use that property from earlier, the product property of 0, to say that we have 2x minus 3 is equal to 0. If I add 3, I have 2x is equal to 3, and divided by 2, and then divided by 2, we have x is equal to 3 halves. Do the same thing for the other term. X squared minus 5 is equal to 0. Add the 5 over x squared is now equal to 5, and take the square root of both sides. X is equal to 5. However, since I took the square root of a square, that means that this is plus or minus 5. So my solutions here are 3 halves, 5, and negative 5. Alright, solve this rational equation. So this easy way for me to solve this rational equation is to multiply, or is to get rid of the denominator. And the way I do that is getting a common denominator so I can multiply it out. So if I multiply, first I'm going to start by looking at this side here, and I notice that I can factor the bottom. So I can rewrite this as 3d squared plus 5. Hold on one second. I'm having some problems with. Okay. Let me rewrite this. There we go. Alright, so I'm now going to rewrite this as 3d squared plus 3 all over d squared minus 5d plus d minus 5. And I can take, and that means I can rewrite this as 3 over this first term, this first term here has a d in it, common, so we have d minus 5, and then this is already in d minus 5, so d plus 1, or d minus 5, so that means we have a 1 there, so that means we can rewrite this as d minus 5 times d plus 1. Since there's no coefficient there, that means it's just 1. So since we have that, we notice that these are same as these 2 roots. So we can multiply the whole thing, or we can multiply each by the other one to get a common denominator. So for this side here, I'm going to multiply each by the other denominator, like so. So d plus 1 plus 1, because that's going to get me this factored form on the bottom. And then the same for over here. Since this is d plus 1, I'm going to multiply by d minus 5. And then that means I'm going to get 4 times d squared plus 4d over d minus 5 times d plus 1 minus d minus 5 over d minus 5 times d plus 1. And that's going to be equal to that 3d squared plus d over, d minus 5 and then d plus 1. So now I have my equation here. I can multiply the entire equation by by d minus 5 times d plus 1 all over 1, and that means I have now eliminated my denominator. So I am left with d squared minus 4d minus d minus 5 is equal to 3d squared plus 3. I am now going to multiply this part out and move everything to the same side. So that means I'll now have d squared. We can combine this to be minus 5d minus 2 is equal to 0. We now have a quadratic, so we can use our quadratic equation. 5 plus or minus the square root of 5 negative 5 squared minus 4 times negative 2 times 1 all over 2 times 1, which this is equal to 5 plus or minus the square root of 25 plus 8 over 2, which is equal to 5 plus or minus the square root of 33 over 2. And we can't really simplify that anymore, so that means that d is equal to 5 plus or minus the square root of 33 over 2. And that is our answer. Alright, so if you need time to write this down or anything, pause the video, but I'm going to erase it since that took up a lot of space for the next problems. So I'm erasing it now, so pause it if you need. Erase this bottom part here. Alright, so solve the following radical equations. We're going to do this by doing the opposite of what we were doing earlier, and we're going to square the square roots instead of square rooting the squares. But the first thing we're going to want to do is get everything to one side to make everything easier, and we're going to have all of our square roots on one side, and then we're going to have all of our other numbers on the other side. So the first thing here I'm going to do is add 3 plus 3 plus 3. So I'm going to be left with 2 times the square root of 3m plus 4 is equal to 8. And then we can divide by 2. So square root of 3m plus 4 is equal to 4. So I can now square each side to get rid of that square root. And I now have 3m plus 4 is equal to 16. Subtract the 4. 3m is equal to 12. Divide the whole thing by 3. M is equal to 4. There. Right, and now we're going to check our solution to make sure it makes sense. We're going to put 4 in here. And so now we're going to have 3 times 4 plus 4. That is equal to 12 plus 4, which is equal to 16. We can have the square root of 16, that's equal to 4. So that means 4 can be a solution. If this was negative 4, that means our radical would be negative and we'd have an imaginary number, and that would not work since we only want real numbers here. All right, for this side, we're going to do the same thing. We're going to subtract 4. Subtract 4. And the square root of 51 minus 14x is equal to x minus 6. We now have everything on each side. We have the radical on the left and everything else on the right. So that means we can square each side. The square root and the square are going to cancel. And then we can FOIL this here. So that's going to turn into 51 minus 14x. And then this is going to be equal to x squared minus 12x plus 36. Now we are going to add these terms over here and subtract this one. And we are going to get x squared plus 2x minus 15 is equal to 0. We are going to use our quadratic formula here to determine what our roots are. And so that's equal to -2. I'm just going to plug the whole radical into my calculator. So that's 2 squared minus 4 times -15 times 1, which is equal to 64 over 2, which is equal to -2 plus or minus 8 over 2, which is equal to -1 plus or minus 4, which means we have x is equal to -1 plus 4, and x is equal to -1 minus 4, which this is equal to 3, and this is equal to -5. We're going to go back and check our radical for each. So we have this radical of 51 minus 14 times 3, which this is going to be, in my calculator, 9, or the square root of 9, which is equal to 3. And then for the other one, hold on. All right, we're it's equal to 3, and then we're gonna plug that into our whole equation now. So we have 3 plus 4 is equal to what was that? 3 plus 2 minus 2. Sorry. 3 minus 2, which is equal to 7, or which goes to 7 is equal to 1. So 3 does not work. We are going to do the same thing for negative 5. So we have the radical. Oh my god. Of 14 minus 5. I'm going to plug that into my calculator. We're going to get the square root of 126. And then we're going to plug that into our equation. In which these are not equal. The square root of 126 is 3 times the square root of 14, and they're just not equivalent. So our answer is x is not equal to anything. There is no solution here. All right. I am going to erase this problem, so if you need to write anything down, pause the video. I'm erasing it now. Alright, and for this side, we have 2 radicals. We can't just go and subtract the radicals. So what we're going to do here is we're just going to square both sides. Here. And so this side is simple. They just cancel, and we're just left with x minus 2. But here, we actually are going to have to FOIL since we have 2 different terms. We have a square root term, and we just have a normal number. So this first term is going to be, I'm going to rewrite this as that times the square root, like that. And so now we're going to FOIL. So this times this, the first, we're just going to be left with 2x plus 3. And if we do the outsides, we're going to have negative 2 times that. Same thing here, we're going to have the same thing. And then the last, we're going to have plus 4. So if we combine everything, we're going to have x minus 2 is equal to 2x plus 7 minus 4 square root of 2x plus 3. And now we can subtract here, subtract here, subtract here, subtract here, and we're going to be left with negative x minus 9 is equal to negative 4 over the square root of 2x plus 3. We're now going to divide the whole thing by 4, or by negative 4, and we are going to get that that x divided by 4 minus, or plus 9 over 4 is equal to 3. And we're now going to square it again. And so now we're going to have x over 16, x squared, plus 9x over 16 plus 9x over 16 plus 81 over 16 is equal to x plus 2. And we're now going to combine like terms. and we're going to convert this into 16ths. So, oops, divide the times the whole thing by 16 over equal to 32x. 16. We're going to subtract this over. And we're going to get x squared over 16 minus 14x over 16 plus 33 over 16 is equal to 0. We can now multiply the whole thing by 16, both sides. 16 minus 0 is 0. Everything else cancels the denominator, so we would just be left with x squared minus 14x plus 33 is equal to 0. And we're now going to do the quadratic formula again. And I'm just going to put this in my calculator to save a little bit of time. So this is equal to the square root of 64, which is equal to 8. So we have 14 plus or minus 8 over 2 is equal to 7 plus or minus 4, which is equal, which that means x is equal to 7 plus 4, and x is equal to 7. Yep. Alright, so that means that x is equal to 11. Oh, hold on, I got a little bit ahead of myself here. X minus 4 is equal to 3. There we go. And so now we can go back into the problem and check it. So we have the square root of 11 minus 2 is equal to square root of 2 times 11 plus 3 minus 2. So that means we have square root of 9 is equal to the square root of 25 minus 2, which that is 3, and that is also equal to 3. Do the same thing for 3. That means 11 works. Do the same thing for 3. We have 3 minus 2 is equal to 2 times 3 plus 2, all squared, minus 2. So that is the square root of 1, which is equal to 9 squared root minus 3, which is both equal to 1. So that means 3 works. So that means x is equal to 3 and 11. Alright. I'm going to erase this problem. So if you would like the work, you can pause it now to copy it down. But I'm going to erase it so I can write out the next problem. Alright. Solve this equation. So, the first thing that we have to do is get like terms on each side. So I'm going to, oops, that's a highlighter. So I'm going to divide everything this by 3 and this by 3 and get x minus 6 to the 2/3 is equal to 16. So now what I can do, like multiplying and dividing, is I can do that the same for the exponents. So I'm going to raise the whole thing by the reciprocal of this, which is 3/2. Same thing here, 3/2. And that basically gets the exponent here to be 2/3 times 3/2, which is equal to 1. So this is just equal to x minus 6. And that means that this 16 is equal to the square root of 16 to the third, which we know is equal to 4 cubed, which is equal to 68, or 64. So that means we have x minus 6 is equal to 64, plus 6 plus 6, x is equal to 70. Actually, since we were doing this, we have to do the plus minus here too. Oh my god. Okay. Half to the 3 halves is equal to 16. So here we also have to plus minus this. Plus minus. So this is plus minus. So that means that we have x is equal x minus 6 equals 64, and x minus 6 equal to -6. Add 6 to both. So this one is 70, and then this one will be negative 58. And so x is equal to negative 58 and 70. Since we are square rooting here, technically, that's what this divided by 2 means. We do have to do the plus or minus thing here also. All right, so that is all that we're going to do for part 2. We're going to do all of 26 in the next video in part 3, so that you have that. So I'll see you guys in the next part.
Okay, last one. We've got, it says to make an appropriate substitution to solve the following quadratic-like equations. So when I'm looking at this, I want to see that I see that same thing appearing twice there, and it looks like that expression 3x plus 7 is squared, and then I see it that where it's not squared. So what I want to do is I'm just going to substitute. I'm going to say u equals 3x plus 7. And I just pick u. You could pick a different letter if you want, just any letter except x. And so we get u squared minus 6u minus 16 equals 0. And then you can, so we get u minus 8u plus 2. So u equals 8 and u equals minus 2 from that. And so then I can go back and plug in what u is into these two to solve for x. So 3x plus 7 equals 8 and 3x plus 7 equals minus 2. And then I can solve both of those. So 8 minus 7, x equals 1/3. And 3x minus 7 equals minus 2. So you can subtract that over. 3x equals minus 9. So x is minus 3. So those are your two solutions there. For the next one, I have y to the 1/2, y to the 4th, minus 6. So I'm looking at my middle one here, and I see that that has y to the 4th. And I know that y to the 1/2 is y to the 1/4 squared. So I can rewrite y to the 1/2 as y to the 1/4 squared. Why is that? Because to get the exponent of this, when you multiply those, so 1/4 times 2 is 1/2. And so that's why those two things are equal to one another. So in this one, I'm going to let my substitution be u equals y to the 1/4, and then I'll go on from there. And so I get u squared minus u minus 6 equals 0. So I can factor that, u minus 3, u plus 2. And so I get u equals 3 and u equals minus 2. So I can go ahead and plug back into the y to the 1/4. So y to the 1/4 equals 3 and y to the 1/4 equals negative 2. So I get y equals, I can take the 4th power of each side. And so 3 to the 4th power is 81. And 2 to the 4th power is 16. And so then I can take, since I have roots going on here, I should go ahead and take those and plug them back into the original equation. So if I plug 81 in, I'll have 81 to the 1/2 minus 81 to the 1/4 minus 6 equals 0. So is that true? So 81 to the 1/2, that's 9, minus 81 to the 1/4 is 3, minus 6 equals 0. So that one checks out. Let's try the other one. So if I have 16 to the 1/2 minus 16 to the 1/4 minus 6, does that equal 0? So 16 to the 1/2 is 4. 16 to the 1/4 is 2. And is this true? 4 minus 2 minus 6 is not equal to 0. So this one should be thrown out. And I kind of suspected that because I have y to the 1/4 equals minus 2 here. And I know that you won't have a negative of a 4th root. So that one gets thrown out. So the only solution here is y equals 81.